Hi, Assalamualaikum. My name is Aizaq bin Askandar. Okay, so we present about the steady flow engineering devices, which is heat exchanger. Okay, so we choose the plate type of heat exchanger, and okay, about the shape, it is just a normal rectangle shape that's stacked between other plates. Normally in the industry, they use stainless steel, titanium, and aluminium. Next, we go to the design. Okay, the design of a plate heat exchanger comprises several heat transfer plates held by a fixed plate and a loose pressure plate to form a complete unit. Each heat transfer plate has a gasket arrangement providing two separate channel systems. Next, the mechanism. There are two types of heat exchanger, which is a single phase and also the two-phase heat exchanger. Okay, for the single phase, the fluids do not undergo any phase change throughout the heat transfer process, meaning that both of the warmer and cooler fluids remain in the same state of matter at which they enter the heat exchanger. For example, in water-to-water heat transfer applications, the warmer water loses heat, which is then transferred to the cooler water, and neither change to a gas or solid. For the two-phase heat exchanger, fluids do experience a phase change during the heat transfer process. The phase change can occur in either or both of the liquids involved, resulting in a change from a liquid to a gas or a gas to a liquid. Typically, devices that employ a two-phase heat transfer mechanism require more complex design consideration than one that employs a single-phase heat transfer mechanism. Next, we're going to talk about the physical features. Okay, with those factors embedded into industry calculations, plate heat exchangers are still consistently found to be the most efficient of all heat exchangers. Typically, they can achieve efficiency rates of approximately 90%. This is because the fluid remain constant along the process. Okay, and then the operating principle and its application. Okay, how it works. The gasket plate heat exchangers optimizes heat transfer. The corrugated plates provide easy heat transfer from one gas or liquid to the other. Plates from a gasket plate heat exchanger are with elastomeric gaskets. These seal channels and direct the mediums into alternate channels. The plate pad is between the frame plate and a pressure plate. It is then compressed with bolts between the plates like this. Um, the upper carrying the bar supports the channel and pressure plate. They are then fixed in a position by a lower guiding bar on the support column. This design is to easy clean and be modified. For example, by removing or adding plates. Okay, fluid runs counter current through the heat exchanger. This gives the most efficient thermal performance, and it is also enables a very close temperature approach. For instance, the temperature difference between the entering and exiting the service mediums. Uh, for heat sensitive or viscous media, cold fluid condensed with hot liquid. This minimizes the risk of the media from overheating or freezing. Okay. For the application, heat exchangers are devices that used throughout industry for both heating and cooling process. Several variants of heat exchangers are available and find application in a wide range of industry. Thank you. That's all from me. I will pass to the my next presenter. Thank you.
Okay, Assalamualaikum. My name is Muhammad Haziq bin Ruslan. Today we are going to see how plate and frame heat exchangers work. So this is the example of plate and frame heat exchangers. Gasket between plates guide the flow of product and heating or cooling fluid through alternating channels. As hot fluid pass over the plate, heat transfer from the hot to the cold side, decreasing the temperature of the hot side and raising the temperature of the cold side. Key to efficient operation, heat exchangers must maintain sufficient fluid velocity across plate to transfer heat while also controlling pressure drop that can disrupt operation. Systems typically employ plate and frame heat exchangers for pasteurization, raw milk cooling, and also CIP or cleaning in place heating. Given their suitability for products with low to mid viscosity and few to no particles, plate heat exchangers are also commonly used for beverages, beer, wood, eggs, sauces, and most dairy processing. Regardless of all design heat exchangers, they are using the same basic principle. Okay, for the basic principle underlying heat exchangers, the first law is zero law of thermodynamics states that thermodynamic systems are in thermal equilibrium, have some same temperature. Furthermore, if two systems are each in thermal equilibrium with a third system, then the two former systems must be in equilibrium with each other. All three systems are of the same temperature. This law preceding the three other laws of thermodynamics in order but not in development, not only expresses thermal equilibrium as a transitive property but also defines the concept of temperature and establishes it as a measurable property of thermodynamic system. The second law is the first law of thermodynamics, builds upon the zeroth law, establishing internal energy as another property of thermodynamic system and indicating the influence of heat and work on a system internal energy and the surrounding environment energy. Additionally, the first law also referred to as the law of conservation of energy essentially states that energy cannot be created or destroyed, only transferred to another thermodynamic system or converted to another form. The second law of thermodynamics established entropy as an additional property of thermodynamic system and described the natural and invariable tendency of the universe and any other closed thermodynamic system to increase in entropy over time. This principle can be illustrated by the following equation, where S represents the change in entropy, Q represents the change in the heat added to the system, and T represents the absolute temperature. Okay, below is the example of the formula that we use in the thermodynamic. It is also used to explain the tendency of two isolated systems when allowed to interact and free from all other influences to move towards thermodynamic equilibrium. As established by the second law, entropy can only increase, never decrease. Consequently, each system as the entropy increase invariably move towards the highest value achievable for said system. At this value, the system reach a state of equilibrium where entropy can no longer increase nor decrease, as the action would violate the second law. Therefore, the only system change possible are the one in which entropy does not experience change. Altogether, this principle dictates the underlying mechanism and operation of heat exchangers. The zeroth law establishes temperature as a measurable property of thermodynamic system. The first law describes the inverse relationship between a system's internal energy and that of its surrounding environment, and the second law expresses the tendency for two interacting systems to move towards equilibrium thermal. Thus, heat exchangers function by allowing a fluid of high temperature F1 to interact either directly or indirectly with a fluid of a lower temperature F2. which enable heat transfer from F1 to F2 to move towards equilibrium. This transfer of heat results in a decrease in temperature for F1 and an increase in temperature for F2 depending on whether the application is aimed towards heating or cooling a fluid. This process can be used to direct heat towards or away from a system respectively. Okay, that's all from me. Thank you.
Hello, hi, Assalamualaikum. My name is Aiman Naim bin Azham. Today, I would like to continue our presentation about how to conserve energy on heat exchanger. As fundamental part of many production processes, plate heat exchangers allow the use of what otherwise would be wasted heat. With energy conservation becoming a major focus for manufacturers, the demand for plate heat exchanger is booming. As fundamental parts of many production processes, they allow the use of what otherwise would be wasted heat. Next, we move to the next slide. In this slide, we will study about the steady flow energy equation for a heat exchanger. During energy analysis of a heat exchanger, we usually neglect the change in the kinetic energy and also change in potential energy because change in kinetic energy and change in potential energy will be negligible for each fluid stream, and therefore we will neglect the change in kinetic energy and the change in potential energy during writing the steady flow energy equation for a heat exchanger. Heat energy will be exchanged between two moving streams of fluid and therefore there will no heat interaction between system and surrounding. Therefore, Q equal to 0. There will not be any work interaction between system and surrounding, and therefore W equal to 0. Then let's see the figure. Cool water enters at the state 1 and leaves the heat exchanger at state 3. Similarly, hot fluid entered at the state 2 and leaves the heat exchanger at state 4 as displayed in figure. Cool water is flowing through the tubes of heat exchanger and hot fluid is flowing over the surface of tubes in heat exchanger. So this is the mass flow rate of cool fluid and hot fluid respectively through the heat exchanger. Applying here the concept of steady flow energy equation, and we will have following energy equation for a heat exchanger. So here the equation. Next, we move to the next slide. In this slide, I will share to you about the impact of the environment, economy, and human health. And the first point is temperature of heating and cooling media. A higher heating media temperature result is a smaller heat exchanger for a given heating load. Limitation of a material must be kept in mind here. The next point is pressure drop permitted by system affect heat exchanger size. Okay, the highest allowable pressure drop will result in substantial saving in heat exchanger size. Next point is line reflection sometimes affect heat exchanger cost. However, there are so many exceptions and limitations and limiting conditions that we cannot simply the longer the cheaper. Material of construction, corrosive tendency and purify requirement of fluid being handled. Often, the choice here is based on reliable data and experience. And then, reduction of carbon footprint as a result of reduced consumption of electricity or fossil fuels. And the last one is the reduction of chemicals required for manual cleaning. That's all from me. Thank you and Assalamualaikum warahmatullahi wabarakatuh.